instead of a constant radius all the way around the center, you're going to have different radii. You're going to be longer in one direction than it is in the other direction. So you need to decide whether the ellipse is vertical or horizontal. And you do that by seeing where the larger number is in the denominator once it's in standard form. So here, A is always larger than B, first of all. So A squared is always bigger than B squared. Okay, that's true for an ellipse. All right, now, A squared is underneath the Y group for a vertical ellipse, and A squared is underneath X for a horizontal ellipse. A, not A squared, but A is going to be the distance that you go from the center out to the edge of the ellipse. B is going to be the center you go in the other direction out from the center. So let me draw some ellipses for you. A vertical ellipse, let's draw it right here. Okay, a vertical ellipse looks like this. Let's say your center's right there. A is supposed to be bigger than B. Okay, so you're going to go A units away from the center in the vertical direction. You're going to go B units away in the other direction, and it will be smaller than A. So yeah, it will make a graph that is longer vertically than it is horizontally. Okay. The horizontal ellipse would look pretty much the same way, except it's going to be on its side. So let's say the center's right there. To get to the edge of the ellipse horizontally, you're going to go A units away. And to get to the edge of the ellipse vertically, you're going to go B units away. Okay? A is always bigger than B, like I said before. So the vertices are always A units away from the center. So the vertices are always the larger distance away from the center, and the co-vertices are always the shorter distance away from the center. So it's like if you were trying to graph a circle, you can't go diagonally the radius unit, so you go left, right, up, and down. Okay, you're going to do the same thing for an ellipse, except you're going to go different amounts horizontally than you do vertically. It's the same principle, though. All right, so you're going to plot your vertices and your co-vertices in the appropriate spots, and then you're going to draw the ellipse connecting those points. All right, you're going to go the amount of units underneath X away from the vertex in the X direction, which would be horizontally. And you're going to go the amount of units, the square root of the number underneath Y, in the vertical direction. Okay, let's try one. So here, the center is still going to be HK. So my center is what? Anybody? 4, -1. Okay, it's still opposite of what you see in the equation. That turned out fine. The vertical or horizontal will be determined by where the larger number is located. The larger number here is underneath the Y group. So therefore it's a vertical, it's larger vertically, so it's a vertical ellipse. Okay. A and B, remember, A is always bigger than B. So A is going to be the square root of the larger of the denominators in standard form. Go. 5. Square root of 25 gives me 5. B is going to be the smaller of the two denominators' square roots. So if I square root 16, I'm going to get 4. Very good. Now we're going to graph it, and then I'm going to ask you to do a few more things. Like I said, we're going to pack everything we can into this first example. Yes, ma'am?
What if the number on the bottom of the equation isn't a
perfect square? Yeah. You can still find the square root. Every number has a square root that's positive or 0. It just doesn't come out nicely, but that's okay. You can go a decimal amount of units away from your center. You just have to approximate. So if it came out to like square root of 2, for example, you would just go 1.414 units away from your center in each direction. Okay. Either horizontally or vertically.
So your graph wouldn't be accurate.
It wouldn't be perfect, no. But no graph really is created by us. Okay, so here we go. Let's graph it right now. So my center is what I need to plot first. My center is at 4, -1. 4, -1 is right there, and I'm going to call it my center. My A value and B value, I needed to decide if it was vertical or horizontal because that tells me which direction to go longer units. So I'm going to go 4 units in the X direction, and I'm going to go 5 units in the Y direction from the center. So you're going to go 5 units vertically away from your center. So you're going to go 5 units up. So 1, 2, 3, 4, 5 units up, 5 units down. Okay, and then I'm going to go left and right 4 units. So I'm going to start back from my center again. 1, 2, 3, 4 units left and 4 units to the right. And my ellipse looks something like this. And you now have the graph of your ellipse. The rest of this that we're going to do is all extension from that, okay? We're going to label the vertices and co-vertices. We're going to talk about something called the foci. We're going to talk about the major and minor axis, okay? So here we go. The vertices are always the farther distance away from your center. The vertices should always go in the direction of your ellipse. So the vertices, which points are the vertices? These two or these two? These two, good. The two up and down from your center. So we're going to label those with a V for vertex, okay? The co-vertices are the other 2 endpoints. So these are the co-vertices. Okay, and I'm going to put a CV on those because co-vertices. Okay. If it actually asks you to list your vertices and co-vertices, you would just name the ordered pairs. You'll have 2 of each. You'll have 2 vertices and 2 co-vertices. Okay. Now, part E, I want to know what's the major axis and the minor axis length. Now, there are formulas for this, but you don't need it if you understand what it's asking you to find. So the major axis and the minor axis. Okay, on your formula sheet it says to multiply the A value by 2 to find the major axis. Well, the major axis is like the diameter of the ellipse. What's the diameter of a circle? What is that? What does it mean? All the way across. So you're going to go all the way across the ellipse in the longest direction. Major, bigger than minor, right? Okay, so major direction means the longer of the 2 directions. So this one happens to be vertical. So what's the longest distance across the ellipse? 10 units. Because you have to go 5 units up and 5 units down from your center. Yes, you multiply the A value by 2, but you don't need to memorize that if you understand that this is the major axis. Okay? This one would be the major axis on a vertical ellipse. This one would be the major axis on a horizontal ellipse. The minor axis is just the other diameter, if you will. Okay? So the minor axis is going to be how long? 8 units. Good. Okay? Now we're going to do something that is called the foci. The foci is plural for focus. Okay? The foci for an ellipse requires you to find something called C. Okay? The foci are always on the major axis, so they're always in the same direction as your ellipse is larger. So here, our foci are going to be vertically away from my center. Reflecting back to here, this tells me that I need to change vertically. So which value am I going to change? My Y value or my X value from my center? Am I going to change the center's Y value or the center's X value? Y value. To go vertically away from your center, you want to change the Y value. You're going to change the height of your point. You don't want to change the X value you're on. You still want to stay in line with the center vertically. Okay? So your Y value is going to change. My X value is going to stay the same. So my X value is still going to be 4. what I need to do to find the foci is I need to add and subtract C to the Y value then. So now we need to find C. Okay? There's a formula to find C on your formula sheet, and it's always going to be there. You're always allowed to use your formula sheet like I told you before. So you don't have to memorize it. However, A squared is equal to B squared plus C squared. This is not the Pythagorean theorem. Just because it involves A, B, and C doesn't mean it has anything to do with that. Okay? But A squared is equal to B squared plus C squared. So we have to find C. What's A and B?
4 and 5.
Mm-hmm. Which one's which? Because it does matter.
A is 5.
A is 5. And B is 4. So 5 squared equals 4 squared plus C squared. And I should be able to solve that. All right. So 25 equals 16 plus C squared. If I subtract 16 from both sides, I get 9. So 9 equals C squared. Square root it. Now let me tell you this. C rarely turns out to be a whole number. Okay, so just get used to the fact that this could be a nasty square root, and that's okay. All right, so you're going to square root. In this case, you get 3. You're taking care of the plus and minus by putting it in your formula for foci. All right, so the foci are going to be 4 and -1 plus and minus 3. So my 2 points are going to be 4 and, if I take -1 plus 3, I get 2. And if I take -1 minus 3, I get -4. So my foci should be at 4, 2, and 4, -4. So if I go to 4, 2, that lands me right there, and I'm going to label it with an F. And 4, -4. Okay, notice they're equidistant from the center. In fact, they're exactly C units away from the center. And C is found by taking A squared and setting it equal to B squared plus C squared. All right. What questions do you have? Again, the foci are always in the same direction as the ellipse is long. So this is a longer vertical ellipse. It's longer vertically, so your foci should go in the vertical direction. They should always be on the major axis, is another way to say that. Okay. So what questions do you have so far? Anything, because this is a good place to get any questions about parts of the ellipse that you have questions on, or even how you come up with certain parts. All right. We're going to move to that board over there. I'm going to steal your desk so you can migrate.
Thank God. Wait.
Don't abuse it. Just telling you. Don't abuse it. Okay. 8. Guys, for this example, things are going to get a little more difficult, not impossible or anything like that. But in this example, I've started you off in a form that's not standard form. So we're going to have to complete the square. Okay? Yeah, and this completing the square, even if you think you understand completing the square completely, you need to be completely tuned in for a lot of this middle part of this example. I'll make sure to tell you when it's going to be more difficult, but right now you need to be paying attention to this part, okay?
Okay.
So, because this will be used in other things than just ellipses. It'll also be used in circles and hyperbolas. We just haven't done it yet. All right, so here we have numbers in front of the squared terms, and they are different numbers. That's what makes this more difficult. And it's what makes it an ellipse, okay? So 2x squared plus 4y squared minus 4x plus 8y minus 2 equals 0. It's all mixed up. First thing to do is to get all the variable terms on one side and the numbers on the other side. So move the 2 away. I'm also going to rearrange the terms so that I have the x terms together and the y terms together. Okay, so I'm going to go ahead and do that. 2x squared, I'm going to put the minus 4x next to it, plus 4y squared, plus 8y, and I'm going to add the 2 to the other side. Okay, now, I could divide everything by 2, but it's not going to solve all my problems. If you want to do that, you're welcome to do it as long as you divide everything by it. However, let me show you how to deal with having a number in front of the squared term, because it's going to happen for every single ellipse and every single hyperbola that isn't in standard form. Okay, so you're going to have to deal with this a lot, I guess is my point. So group the x terms and group the y terms. So far nothing's different. You're going to factor something out that's in common with both of them. And we talked about this third period. We don't want to factor any of the variables out. Okay, we just want to factor out numbers. So I'm going to factor out a 2, and you always want to factor out the thing that is in front of your squared term. Even if it doesn't go into the other thing evenly, you want to factor that out, because otherwise your standard form isn't going to have, it's not going to be in standard form. You'll have a number in front of your variable, and that's not standard form. Okay, so factor out a 2 from the x group. That gives me x squared minus 2x. Don't drop that second x, and I don't want anybody to get confused. Right here, we have not completed the square yet. Just because you put a set of parentheses doesn't mean you have a quantity squared. Okay? You haven't completed the square yet. You just factored out a number in front. Okay, let's do that with y as well. What should I factor out of y? A 4. So I'm going to pull a 4 out in front, and that's going to leave me with y squared plus 2y equals 2. I've done it. Okay, I've done that. Now, ladies and gentlemen, you need to complete the square at this point. Okay, so what perfect square factor group gives me 2x for a middle term? X minus 1. Yeah, you take that thing and you split it in half. So x minus 1. Okay, now the 2 is still out in front of that quantity, and because it's a real strong temptation for me to forget this part, I go ahead and do this now. Okay, I complete the square. I balance the other side of the equation with that group. So if normally we would then square the 1 and add it to the other side. But the problem is that you're not really adding 1 to this side, you're adding 2 times 1. You have to multiply what you factored out by that number. Okay, so you need to actually add 2 to the other side to balance the equation with that perfect square group. That's the difference. That's a huge difference from from completing the square before, because if you forget to multiply by that number in front, A, you're going to come up with the wrong answers, and B, sometimes it won't even work. Okay, so plus 4 times what perfect square factor group gives me a 2y middle term? Plus 1. Okay, so y plus, I'm going to divide this by 2, and that gives me a 1 right there. What do you need to add to the other side to complete the square and balance the equation? 4. Okay, because 1 squared gives me 1. Multiply that by 4, and I'm then going to need to add 4. You said 4. I wrote 8. Sorry. Okay. On the other side, though, I get 8. Okay. Now, this is close. It's not quite in standard form yet, but at least you have perfect square factor groups. That's half the battle or more. Okay, because now both of your standard forms are equal to what number? 1. They're both equal to 1. So now all you need to do is get equal to 1. How do you turn 8 into a 1? Divide by 8. So you're going to divide both sides entirely by 8. Okay, I'm going to end up dividing each term by 8, so I'm going to do that right now. Okay, so you have, I'm going to rewrite it just because I think it'll confuse people less. Okay, so 2 over x minus 1 quantity squared all over 8 plus 4 times y plus 1 all quantity squared all over 8 equals 1. What can you reduce?
The 2, 8, and the 4.
The 2 and the 8 and the 4 and the 8. So 2 and 8 reduce to leave you with what, and where is it located?
The 4
A
on the bottom.
4 in the denominator. Okay, it's like 1/4, but you have 1 on top and 4 on the bottom. What does 4 and the 8 reduce to? A 2 on the bottom. Okay, so your standard form equation is x minus 1 quantity squared all over 4 plus y plus 1 quantity squared all over 2 equals 1. That's standard form. So now we can do everything we just did in the last example. We're only going to do some of it. Okay, we're not going to do it all. But do you have questions on how to come up with that standard form? Because now would be a pretty good time to ask them. Do you have questions up to this point? Really? Your instructions don't say put it in standard form. Sometimes they will. Okay, but if they say find the center, vertices, and foci. Okay, so we're not quite done, but we're close. What questions do you have so far? Okay, let's try it. Find the center. Anybody? What's the center? There's the standard form. 1, negative 1. Very good. 1, negative 1. Because it's always opposite of what you see, remember? Okay, it's x minus h. The h value is your x value of your vertex. And y, or center in this case. And y minus k. All right. The vertices, to decide the vertices, I could make a graph. But let's not make a graph for right now. Let's just decide, is this a vertical ellipse or a horizontal ellipse? Oh, it's a horizontal ellipse. So therefore, what should you change? To change horizontally, you should change what? The x or the y? X. So you're going to change x. Or you're going to go x units away. Maybe I should put it that way. Okay? So you're going to go vertices. Let's see. My y value is going to stay the same. To find the vertices, I need to go a units away from my center. So I'm going to go, let's see, see how the larger squared number is under x?
Yeah.
So you're going to go that many square root, that many units away from your center x value. So the square root of 4 gives me 2. So my a value is 2. Maybe I'll write that down. Okay, so a is equal to the square root of 4, which is 2. So I need to add 1 plus and minus 2. So my vertices are going to be 1 plus 2, 1, and 1 minus 2, 1.
It should be negative 1.
Why? Oh, the second one should be negative 1. Got it. Thank you. It's all worried about the x value, not the y value. It matters, though. All right, so I get 3, negative 1, and negative 1, negative 1. If you were to graph these, they would be perfectly horizontally in line with your center, and that's what you want. All right? Now we're going to find the foci. To find the foci, I need to find C. How do I find C? Yep. A squared equals B squared plus C squared. Here you go. Mathematically, what's A squared?
No.
4.
4.
A squared is the thing, that's temptation though. A squared is the thing you see in your equation. So you don't really need to find A before you can tell me what A squared is, since it's already in your equation. All right, so A squared is 4. What's B squared? 2. So 4 equals 2 plus C squared. Subtract 2, and you get 2 equals C squared. What's C equal to? 1.414, or the square root of 2. If you want to leave it as square root of 2 because you're not graphing this, that'd be okay. All right, that's fine. Do I need to change the x value or the y value? Same one you did a second ago. You still want to be on the major axis, so you still want to go in the direction of the ellipse. The example we just did a minute ago was a vertical ellipse. That's the reason we changed the y value. This one is a horizontal ellipse, so you're going to change the x value. Okay, so you're going to, the foci are going to be 1 plus and minus the square root of 2 and -1 for your y value. If you want to find out what decimal that is, that's fine. Or values rather, because it's 2 of them. Okay, but you don't have to because you're not asked to find, you're not asked to graph it, so it's not right. When you're asked to graph it, you actually have to mark the foci, so you're going to want the actual decimal value. Does that make sense? Okay, I'm going to pause.